Hey guys, I hope that I'm audible right now. If you guys are able to listen to me properly, as well as there's no issues with the audio or the video, please do let me know, guys. Good evening, everyone. I hope that I'm live right now. If you guys are able to listen to me properly, as well as there's no issues with the audio or the video, please do let me know, guys. Hello, everyone. Hello, hello. If there's any issues with the audio or the video, guys, please let me know. Actually, I was not well yesterday. I had a bit of cough and fever. That is the reason why I was not able to take up yesterday's class. But don't worry about it, guys. We'll be extending the boot camp by 2 days. Okay. So you'll be having two classes tomorrow and day after tomorrow as well. Like I said, it's my duty to make sure that you guys are able to learn everything properly. So you don't have to worry about that. Okay. Good evening, everyone. Good evening. Okay. Good evening, everyone. So we'll be extending the class by 2 days, like I've said in the live chat as well. Okay, so we'll be extending the bootcamp by 2 days, so don't worry about it. And yesterday, I was not able to take up the class because I was not well. Okay, but we'll be having the classes from today onwards regularly. Okay. Okay. Good evening, everyone. Good evening. Okay, so as far as that goes on, today, tomorrow, we'll be learning about deep learning. Okay, and day after tomorrow, we'll be having our project. So that will be the entire stuff. Without learning deep learning, you cannot go into the project directly. Okay, so that is the reason why. First of all, we'll be learning about deep learning, and then we'll be going into um, the project. Okay. Customization, slow seconds for right now. Okay. Uh. So what have we discussed in our last class? Can somebody let me know? What are the different stuff that we have discussed in our last class, guys? Can somebody let me know what are the different stuff that we have discussed in our last class? Okay, data science. I gave you guys an introduction to AI and what are the different subdomains of AI. Am I right? I've given you a brief introduction about AI and the different versions of AI as well. Am I right? Okay, great. In today's class, we'll be starting on with deep learning. Okay, so let's get started as soon as possible. Give me a second. Let me just open up my paint itself. Okay. So now, like I said, back in 1950s, the researchers around the globe associated artificial intelligence with basically recreating human intelligence artificially. Okay, so what is the part of the human body that makes us intelligent? Can somebody let me know? What is the organ inside our human body that makes us intelligent? Can somebody let me know that? The brain, exactly. The researchers decided that yes, the brain is the like part of our body that basically makes us intelligent. So we need to, if we want to recreate actual artificial intelligence, we need to recreate the brain artificially. Now, the brain itself is a field of science that is basically called as neurology. As you're able to see, researchers started studying about neurology a lot. They started taking up inspirations from neurology. So when you're looking at a brain is basically consisting upon of cells that are called as neurons, okay? And these neurons look something like this. If you are familiar with neurons, I think so in biology you must have seen about neurons itself. Looks something like this. So this is how a neuron looks like. Okay, this is how a neuron looks like, a neural cell looks like. Now this is the basic building block of your brain. Okay, this is the basic building block of your brain right over here. Now how does a neuron functions? Okay, like a brief overview of how a neuron functions. So basically electrical charges, okay, electrical signals are passed on from right over here to the nucleus of the neuron, where the decision making basically occurs. And that electrical signals, now whatever decision making that occurs in the neuron, gets transmitted further on to the axon, to the tentacles, which then gets forwarded to a muscle, maybe forwarded to another neuron or something like that. So that is how a neuron basically works. Are you familiar with neurons, guys? How a neuron basically functions? Are you familiar with this concept about electrical signals traveling through the dendrites, then the decision making, what those electrical signals are then interpreted, and then the decision making happens inside your nucleus of the neuron itself, and whatever decision has been taken up on the neuron in the nucleus then gets transmitted through the axons, through the tentacles, through to other muscles or other neurons as well. Are you guys familiar with this? So this is how, like, your brain, inside your brain, your neurons, they keep on firing these electrical signals, taking different decisions, and cumulative, they are able to build upon it as well. Okay, guys, I forgot about the resume for today's class. In tomorrow's class, I will show you guys the resume as well. Okay, don't worry about it. So as you're able to see right over here, these electrical signals gets transported further on to be used somewhere else. And that is how your neuron, the building block of your brain, basically functions as. Now the researchers who are currently there, they decided that we need to create an artificial neuron. We need to convert this neuron into a mathematical equation. Okay, we need to create a mathematical equation that resembles this neuron itself. And through that, they created something called as an artificial neuron. This artificial neuron looks something like this. This is the neuron. This is the artificial neuron right over here. It takes in electrical signals inside as input. Okay, it takes in two electrical signals inside as an input. It does some computation. Right over here, and it produces a result at the very end. As you're able to see, this looks very similar to the normal neuron. It takes in inputs, okay, just like a normal neuron takes in inputs. It does some computation in the nucleus of the neuron as well. It does some computation in the nucleus of the neuron, and then it passes the output to the further neurons or to the further muscles and everything. As you're able to see both of them, this is the artificial neuron and this is the normal biological neuron. So they decided that they need to model this artificial neuron on the basis of this normal neuron itself, and they created this artificial neuron. This artificial neuron that you are able to see right over here functions something like this. You are having the neuron, the artificial neuron right over here. It takes in two inputs. Okay, it takes in two inputs. This is the first input and this is the second input right over here. Okay, the first input basically is your x naught. Let us consider it as x naught. That is your first input. The second input is let's see, x1. Okay, let's take x1 as your first input. The second input is x2 right over here. Okay, then you're doing some computation. Okay, and that computation results to you an f of x comma x1 comma x2. Okay, f of x1 comma x2. Now, can somebody let me know what is the mathematical equation for a function in two variables? This is a normal maths function that you have already studied in your 10th standard. Okay, what is the function? If I'm telling you to write an equation, if I'm telling you to write an equation in two variables, what is the equation that you will be writing, guys? Can somebody let me know that? This was normal 10th standard mathematics, nothing too new about it. Can somebody let me know? Like if I'm asking you to write an equation in two variables, what would that equation look like? This is nothing related to deep learning. Okay, like I said, yeah, that's absolutely clever, Dinesh. The equation would be z is equals to ax plus by plus c, right over here. Ax plus by plus c. Now you are having two variables. You are having x1 and x2 right over here. You need to convert this. Okay, you need to convert this f of x1 comma x2 into a function of two variables. So it will look something like this. So f of x1 comma x2 is equals to ax1 plus bx2 plus x plus c. Let us take it as plus c. This is how you will be representing a function of two variables. Okay, equation of two variables right over here. Now as a, b and c is something that we can write anything right over there because these are constants. So we are using any particular words that we want to use. We can again write this equation in a new format, and that will write it as f of x1 comma x2 is equals to x1 w1 plus x2 w2 plus x naught. Okay, plus x naught. So we are writing the exact same thing, just that we are replaced a by w1, b by w2, and x naught by c by x naught. Are you guys able to understand from where I'm able to get this particular equation? Are you guys able to understand from where we are able to get this equation, guys? Are you guys able to understand from where we are able to get this equation? Please let me know. If you're not able to understand, write exactly what you're not able to understand. Okay, this is 10th standard mathematics. There's nothing new right over here. I'm trying to make sure that there's nothing new right over here. You're able to relate to it as soon as possible. Okay. For those who are not able to understand, write exactly what you're not able to understand. Because like I said, it's just 10th standard mathematics. This is nothing new to it. Okay. I don't think so it's 10th, and I think so it's 9th standard mathematics, not even 10th standard. Okay, great. So I've done a quick revision as well, so that those who were not able to recall it are able to recall it as well. Now this exact same thing, x1 w1 plus x2 w2 plus x naught, we need to represent it as a image as well. Okay, like I said, w1 is basically I'm representing a as w1. I'm writing w2 as b. Okay, just to make things a bit more clear, we are writing c as x naught because these are like constants. These are constants. So I can write anything right over there. I can write Shaurya x1, Drumel x2, Mahi x3. Okay, I can write anything right over there. Okay, your x1 and x2 are the variables. The rest of them are constant. So I can write it, I can represent it as anything. Okay, so just to make things like a bit more like easy to remember, so because it's x1, so I'm writing a as w1. If it's x2, I'm writing like b as w2, and if it's c, I'm writing it as x naught, just to remember it correctly. Okay, so right over here I can represent the exact same thing, that is f of x1 comma x2 is equals to w1 x1 plus w2 x2 plus x naught. And now I can represent this as an image. I can represent this as an image right over here. So this is our neuron, artificial neuron. We are having x1 as our input, x2 as our input, and an x naught as well. So this x naught right over here, let's take up the x naught. That is also constant. Now what we are doing is we are multiplying. Okay, we are multiplying x1 by w1. Okay, so we need to write w1 right over here. We are multiplying x2 by w2. Okay, we are writing x2 by w2. So we are having x2 right over here. So w2 right over here, and we are multiplying x naught by 1, so you can just write 1 or you can ignore it as well. There's no issues. So x1 w1, then you're having x2 w2, x naught into 1, and then you are summing it. Okay, you are doing a sigma, that is a summation of all these multiplications. You're doing a summation for all these multiplication, and that is getting you the answer of f of x1 comma x2. Are you guys able to understand this particular layout? Okay, are you guys able to understand this particular layout, that you're multiplying x1 w1, okay, then you are multiplying x2 w2, then you're multiplying x0 into 1, then you're adding them up, and that is how you are able to get the f of x1 comma x2. This is the visual representation of this equation. This is the visual representation of this equation. Code bulletin, please be patient. We have just started. Okay, I cannot rush things further. I can just say that, okay, this is a neuron, this is the fucking thing. We are done with the project. Let's move on. Try to make sure that we are going from the scratch. Okay, so please be patient with me. Okay, so once you've understood this, now let's try to understand. Okay, so any type of prediction that you want to do, you will be utilizing this particular equation. Okay, but sometimes you want your answer to be a bit more specific in nature. For example, your f of x1 comma x2 is a probability. Okay, f of x1 comma x2 is a probability right over here. So if you're having a probability, okay, so won't it be a of x1 to the power n1? Okay, that is not a function, like equation in two variables. Okay, this is like you are making a polynomial equation right over there. This is not equation in two variables. Okay, please try to revise it as soon as possible. Yes. Okay. Okay. So right over here, as you're able to see, what I was discussing about is sometimes the result. Okay, so for example, x1 and x2 are, let's say, your humidity. Okay, the values of humidity and the values of temperature in your city. Okay, x1 and x2 is the value of humidity and temperature in your city. Okay, you want to predict the probability that will it rain today or not. Okay, so x1 is, let's say, your humid, and x2 is your temperature of your city right over here. Okay, and you want to predict the probability that it will rain. Okay, so can somebody let me know what is the range of values that probability can take? What is the range of values that a probability can take, guys? Can somebody let me know? Can somebody let me know what is the range of values that probability can take? That's absolutely clever. The values that probability can take should lie between 0 to 1, including both of them. Okay, it cannot be more than 1. It cannot be it cannot be more than 1. It cannot be less than 0. Okay, so now there's a big problem. Okay, this f of x1 comma x2, you're taking an input as humidity, you're taking output as input as humidity and temperature. Now humidity and temperature is in different scales. These are different big values right over there. How are you going to make sure that your f of x1 comma x2 has its value always in between 0 to 1? How are you going to make sure of that? That is the major question right over here. This is where the concept of activation function comes into place. So instead of just having a sigma right over here, okay, so for example, f of x1 comma x2 is some value. I don't know what value is that. It's some value. How to make sure that that value is always between 0 to 1? Okay, for that you are having a concept of activation function. One of the activation functions, let us take up an example, is the sigmoid function. Okay, it is the sigmoid function that looks something like this. This sigmoid function, the value lies between 0 and 1. So whatever is the output right over here gets passed on. So if this is like 104, okay, this is 104 as the output right over here. So what we'll be doing is, what will be, Nitesh Rana, I think so you are late in the class. Like I said, please watch the class from starting. It's not like if you are late in the class, that's your problem. I cannot stop the class. There was just one person who is late. So we'll have to rewatch the entire video. I've explained it correctly. Okay, please be on time. If you're not on time, there's nothing that I can also do for you. Okay, so you are the output f of x1 comma x2 for some value of humidity and temperature is 104. You'll pass that on to an activation function. So maybe 104 is coming right over here, 104 is coming right over here. So you will get the value of probability around 0.8. Okay, that is 0.8 that is it's 80% probability that it will be like raining today, 0.8% probability that it will be raining today. So your equation of f of x1 comma x2 gets passed on to an activation function called as a of like that's called as a, like it's represented as a itself. So right over here, instead of just having the summation, now it is in two particular layers. Okay, now it is in two particular layers. The first half is the summation. Okay, that is where you are getting your f of x1 comma x2. Then it is getting fed into an activation function that gets fed into an activation function right over here that leads your answer. Okay, now your answer gets converted to, just delete it from right over here. Now gets answer created to, okay, right over here as g of f of x1 comma x2, where g is the activation function. So whatever value that you're getting from the summation, okay, maybe it's 104, maybe it's 105, then gets transferred into the activation. That's the input from the activation function itself, and then you move further with it. Now, for example, the sigmoid function, okay, the sigmoid function that we saw right over here. Give me a second, guys. I'm so sorry, I'm not feeling well today. Okay, so the formula for the sigmoid function that we saw, that ranges between 0 and 1. So this was the sigmoid function that we were having. Now the function for the sigmoid function, g of x, would be equal to 1 by 1 of 1 plus e to the power minus x. This is one of the examples of a activation function. So whatever value you are getting from f of x1 comma x2, that becomes an input inside this activation function, which then gives you your final answer. Are you guys able to understand this? Please let me know, guys. Activation, there are a lot many number of activation functions. We will be looking into them. There are step functions, there are the Relu function, there is the activation function, there is the linear function. Okay, so please let me know if you guys are able to understand this. Great. So let us try to understand some other activation functions as well that are there. Okay, so one of the activation functions that is there is the sigmoid function that we have already told you guys. Okay, the next function is called as a Relu function. Okay, Relu function. The Relu function basically exists something like this. Okay, before up till 0, up till the point where x is equals to 0, the answer is always 0. Up till the point when x is equals to 0, the answer is always 0. And after x becomes positive, okay, after x becomes positive, it becomes f of x is equals to x. Okay, so y is equals to x basically. So it's 0 from x if x is less than equal to 0, and if it is equal to x when x is greater than 0. Okay, so f of x is equals to 0 when x is less than equal to 0, or is equal to x when x is greater than 0, right over here. This is called as a Relu function. Now, can you give me a case? For example, for probability, we use the sigmoid function. Okay, for probability, we use this sigmoid function. Can you guys give me an example? Okay, can you guys give me an example of a case where we can use the Relu function, guys? Can somebody give me an example of a case where we can use a Relu function? I'm so sorry for my voice. Actually, I'm not feeling well. That's the reason I wasn't able to have the class yesterday. I don't know why. Like I'm an asthmatic patient basically. So sometimes I have these asthma attacks where like I'm not able to breathe properly. So that is why I was not able to take up the class yesterday. So I'm extremely sorry if there is any problem with my voice, but I will try to make sure that you guys don't suffer about it. Okay, can you guys let me know, like, an example of a case where you can use Relu? Percentage or precipitation, like how much will it rain? Now again, percentage is also between 0 to 100. You cannot have 150. You cannot have less than 0 as well. That will also be a sigmoid. That will also be a sigmoid right over there. Okay. Give me some example of a Relu function, because see, up till x is negative, your answer is always 0. Okay. Above that, it is f of x is equals to x. Okay. Temperature can be negative, guys. Temperature can be negative, so you cannot have temperature as the answer for Relu. Think about it. Think about it. What is the case in which you cannot have the value as something negative? You cannot have the value as something negative. The toss of a coin is also having just binary indications. Either it is 0 or it is 1. That is also not something that we can take up. Speed. Okay, so speed is a good example. Okay, speed. We can take up speed as an example. Weight as an example. But these are not something that you can like predict. Okay, what is the speed of light? Okay, something you can predict or something like that. That is would not be a good example right over there. So one of the examples for this is predicting. Okay, predicting. What can you predict? Predicting the value, the price of a particular item. Predicting the price of a particular item, like predicting the price of an NFT. That based upon the previous trends, based upon the historical data, based upon the news articles that are there on this particular NFT, the pricing of this NFT would be this many ethers. Okay, so that is a good example. Or based on the BHKs and the floor plan and the location of a particular house, this will be the price of a house. Can the price of a house be negative, guys? Can the price of a house be negative? Can the price of a house be negative, guys? Please do let me know. No, the price of a house can never be negative. So that is a place where you can use the Relu function to get a particular price of the house, because price cannot be negative. The price of a particular stuff cannot be negative. At least it would be 0. It cannot be negative right over there. So that is where you will be using the activation function of Relu. Then, for example, you want to take up toss of a coin. Okay, you want to take up toss of a coin. For that, you are having the binary activation function. You're having the binary activation function that looks like this. Okay. Whenever the value is 0, whenever the value is, let's say, 0, the answer is 0 itself. Okay. It's like, okay, no. Not 0. Okay, not for 0. Okay, whenever the value of x is 0, the answer is 1. Whenever the value of x is less than 0, it is -1. So this is the binary classification. Okay, so this is -1, this is 1, this is 0. Whenever the value of x is 0, the answer greater than equal to 0, the answer is 1. So this would be f of x is equals to 1 whenever x is greater than equal to 0, and -1 whenever x is less than 0. Okay, that is the binary function. This is where you will be using, for example, predicting the toss of a coin. Okay, whether a particular person will be able to survive from Titanic or not. So there can be only two things: either he or she is able to survive, or he is going to die. So survival rate of a particular person from Titanic, you will be using this particular function. Okay, are you guys able to understand? Wherever you want to use something that is having only two binary classification, that either something will happen or something will not happen, that is where you are using a binary activation function. Okay, binary activation function. Are you guys able to understand this? Please let me know, guys. Okay, so just like this, there are many other activation functions that exist that you can use at any point of time. Okay. Okay, great. So now you need to understand that just taking up, okay, just taking up a normal, okay, just taking up a normal Okay, Om Golap hasn't understood the use of Relu function. See, up till like whatever the value of x is till 0, okay, before 0, the value of y will always be 0. It will never be negative in nature. Above that, whenever x is positive, the value will always be positive. So, for example, anything that cannot have a negative value, for example, predicting the price of a house, it cannot be negative. It can be 0 at the least. That is where you use the ReLU functions. Okay. Karthi, even if you're not from like a normal maths background as well, but still you must have studied maths up till 10th standard and they teach you about functions. Okay, in 9th standard you have functions in your syllabus itself if you have been from a CBSE board. Okay, and these are just normal functions. Like I'm just making these functions up. You don't have to worry about it. It's basic itself. Okay. Okay, the next thing that we need to focus upon is understanding some of the concepts, okay, such as what is your supervised learning, what is your unsupervised learning. Okay, so these are the two things that we need to learn about. Okay, so just first let us try to understand this. Okay, let us first try to understand this. Relu can also be used for binary prediction also, right? The person will try or not, as there is no negative value. Om Gulab, you could even like eat food by putting your mouth directly inside the plate. Okay, you can do that. But is that the right way of going further with this? God has given you the brain power to basically have a spoon and a fork to be able to eat some food like a normal human being. Okay, so that's the same thing right over there. Yes, you can use any function to do anything, but which will be the most accurate one? One that has already has a binary classification, or one in which like this is a positive and negative value. That is the main thing that you have to do it. Okay. Okay. So right now we need to understand one more thing. Now a basic artificial neuron basically has a function of g of f of x1 comma x2. Now this function that we created right over here that looked something like g of w1 x1 plus w2 x2 plus x naught right over here is a very basic function. Okay, it's a very basic function right over here. So you need to make sure that this basic function, okay, on its own won't be able to do shit. Okay, because how many values can it take? A very less number of values. How many decisions can it take? A single neuron. Your brain does not work via a single neuron right over there. Okay, all the neurons continuously talk with each other, continuously fire at each other, and then take a decision collectively. Okay, so the power of the brain lies in the neuron itself. Now the same thing happens in like your artificial neurons. Okay, just a single artificial neuron, okay, is not that powerful, is not that powerful. But what if we are able to group together millions and even billions of neurons together? Then that function, this function would become so complicated that mathematics can never be done. Mathematics on deep learning can never be done, because we are talking about millions and billions of equations getting passed to each other without any sense. Okay, so that is why the basics of mathematics is up till here. After that, it's just based on intuition. So what researchers did was they started grouping neurons together and calling them as layers. Okay, for example, if you're taking up the if it will rain or not. Okay, if it will rain or not, let's take up that particular example right over here. There are various different aspects that you will have to check. What is the humidity? What is the temperature? Is it cloudy? Is it sunny? Is it rainy? What is the wind speed? Okay, so there are various different inputs that you have to take. It's not just two inputs. Now there are various inputs, maybe 10, maybe 20, maybe 1,000 inputs that you have to take at a time. Okay, so what they did was that instead of taking a single neuron, they started grouping neurons together into one particular layer, like grouping together, and called them as a neural layer. Okay, this is called as one neural layer. It's called as one neural layer. And then they started attaching multiple neural layers together. They started attaching multiple neural layers together. Okay, so this is your secondary neural layer right over here. Okay, let's take it up as a secondary neural layer. Now it is not necessary for both the neural layers to have the same number of neurons. One can have like 32, one can have like 512 neurons as well. It's not necessary for them to have the same number of neurons. But a good thumb rule is to have the number of neurons in a particular layer as the power of 2. Okay, as the power of 2. Now there are various different research papers that I've read about why this is the best number to take up. Okay, but usually what I am able to understand from it is that power of 2 becomes very easy for the computer to process and provide better results in less amount of time. That is the reason why you should consider the numbers to be in power of 2 itself, of neurons in a particular layer. Okay, so again, this is not compulsory. You can take it up like 3, 4, 500, whatever you want, but usually take it up as power of 2. Okay, so now what they did was, for example, these are my inputs. Okay, so I will feed in the same input in every single neuron. Okay, so this is my humidity. Okay, so is this humid? Okay, then I'm having my rain. I will then again feed it up in all the other neurons as well. Then I will have another type of neuron right over here. Let's say I'm having speed. Okay, wind speed. So I'll feed it in all the neurons as well. Like I can choose like to omit 1 or 2 neurons. Like it's fine. It's not compulsory to feed it in all the neurons. You can feed it in 1 or 2 neurons as well. It's totally fine with that. Next, what I'm doing to do is all these inputs where we are generating like f of x, then g of f of x, and all those kind of stuff. So it becomes a very big, each of these will have like an individual function associated with it. Now I will cross-reference all these, will put these as inputs to my next layer. The output from these neurons, the output for these neurons will be the input for the next layer of neurons. Are you able to understand how complicated the new function that will come from right over here will be? How complicated the new function that will come up from right over here will be? Are you guys able to understand it? Please let me know, guys. We'll be looking at, Garima, how this like works. Okay, right now we are trying to get a conceptual view of it. Okay, we are trying to get a conceptual view of it. Okay, so and these then together, like these functions become so complicated that at the end you are getting your output. At the end you are getting your output. So these like work exactly like your brain. Now, as neural networks was discovered back in 1950s, but at that point of time, the computer, so you are able to see how much complications, how much computation has to be done to create a normal neural network. And usually when you're creating a neural network, it will be like 10 layers of like 1000 neurons in each layer. So it's like a big deal. It's a big, very big computation right over there. Okay. And so that your laptop doesn't have enough power to do these type of computations. For that, you require GPUs. Okay. You require GPUs to be able to handle these computations for you. Now, of course, like for example, I have a GPU that is the RTX 3060 and the RTX 3070. So I have both of them right now with me. 3070, I guess I have Super, and 3060 Ti. I feel I have these two. So with my workstation and my laptop. So these GPUs are very like costly to basically use or get at any point of time. Not everybody has these GPUs as well. So for example, running a particular neural network on, let's say, CPU, you can run it on CPU as well, but it will take like 3 to 4 days to run a normal code itself. So I think so it would be 3060 Super and 3070 Ti. I'm not very sure about it, but I have these two GPUs with me. So as you're able to understand, like on CPUs, it will take 3 to 4 days to run a particular code. Okay, to run a particular code, it will take you 3 to 4 days to run a normal code on a CPU. Now, because CPU has less number of threads, it is able to not do that many number of computations at the same point of time. So it takes a lot of time for the code to run on CPU. Now, when it comes to GPUs, it is able to do it a lot much quicker. So for example, if it is taking you 3 to 4 days on your CPU, it will take to, if you are having a good GPU, it will take you like 3 or 4 hours to do that on GPUs. Now, there is another equipment that is called as a TPU, or Tensor Processing Unit, that has been developed by Google. Okay. that has been developed by Google right over there. They are much more faster. They have been developed for only training these neural networks itself. Okay, so you must have heard about like Google releasing the Google tensor chip in their mobile phones as well. So basically that is like a higher powered version of GPUs, and it is able to do like parallel computations very quickly. So if it is taking you 3 to 4 hours on a GPU, it will take you like 30 to 40 minutes on a TPU. That is the power, the computational power that is actually required by these like deep learning code to actually work. Like it's such that I've already wasted almost two of my laptops. One of it was my MacBook Pro from 2016, and the other one was the HP Pavilion X360 with the i7 10th gen processor. Both of them, the motherboard got burned because I had to continuously run my code for like 3 to 4 days. So this is not at all good for your laptop. Okay, so be prepared to like lose at least one or two laptops if you're doing it locally. That is the reason why I usually suggest students to go on Google Colab and run your code, because you don't care about it anymore. Like even if it's burning, it's like Google's property, you are using it for free, and Google provides you on Google Colab support for CPUs, GPUs as well as TPUs for free. For free, you don't have to worry about it. Shouldn't one layer have the same results? So you don't put in all the inputs to all the neurons. Okay, not every input goes to every single neuron. You try to create computations, you try to create different combinations right over there. The second thing is every neuron will have some other values of W0, W1 and W2. Okay, so X0, W1 and W2 are like values that are different for every single neuron that is there. So that is the reason why like every neuron has a new function that it creates. Okay, Abhijit, I hope that I was able to answer your question. Okay, now back in 1950s to 1970s, even till 2000s, the entire like community, the entire like computation power that was available in the market, like your smartphones right now are much more powerful than the supercomputers back in that particular point of time. So researchers thought that this concept of deep learning is just theoretical in nature and it cannot be implemented in code, because at that point of time your mobile phones were like supercomputers. So they didn't have the computational power to actually execute these deep learning codes, and that is why the research on deep learning got slow and like it slowly died. And then in 2000s the interest on deep learning gradually increased a lot, because the computation power was increasing due to the Moore's law, and slowly and steadily like people were able to get the grasp of this computation power paired with deep learning to be able to give you like your Google Pixel, your Google Assistant, your Siri, your Alexa, your computer vision based cars, whether it be your Tesla, whether it be other companies as well. So all these at some level or the other use deep learning in their applications to be able to create something. Okay, so deep learning is that important right over there. Okay, okay. So we have learned about the inputs, we have learned about the layers, we have learned about the neurons right over here. We have understood the concept of deep learning. Why do we require GPUs, CPUs, and TPUs right over there? Okay. So while doing deep learning, the best possible library to use is the TensorFlow library. We will be using TensorFlow library right now as well. Okay. So Python and deep learning certificate didn't get some people. Please reply. Like I said, certificates, we take some time to send out the certificates. Right now, we have just posted up the project video for deep learning. The project submission for deep learning is now open. So we are, either it's deep learning or no? Was it deep learning or machine learning? I think so. It was machine learning. No, it was data visualization. So data visualization project has just been posted. It will take us some time. Once the submission for that is over, then we'll be submitting out, sending out the certificates. Okay. Okay. So up till now, do you guys have any doubts, any queries? Are you able to understand the concept about deep learning, guys? This is basically called as ANN, okay, artificial neural networks, because now you are creating a network of artificial neurons. You're creating a network of artificial neurons. Let me try to find out an interactive code that I was able to find. Interactive um deep learning in IT. Mm, learning will I let us see if I'm able to get a visualization that I am able to create right over here on this one. I had saved it somewhere. Now I'm not able to remember where I had saved the interactive dashboard that I created. To find it right now. Okay, no issues in that. Let me do one thing. I will keep that in mind. In tomorrow's class, I will bring in an interactive visualization of how these neurons actually work. There's a lot many number of things that you will be able to find it from right over there. I will give it to you guys. It will be your duty. I will be giving you the link in tomorrow's class. It will be your duty to basically go through the entire like visualization project that they have created. Whatever different things that you're able to see and you're not able to understand it, search for it, learn it, and then come to tomorrow's class. Will that be fine? The day after tomorrow's class, because then we'll be having our project day after tomorrow. Are you guys able to understand it? Please let me know, guys. What are you talking about? I'm talking about the data visualization bootcamp. That is a dusra bootcamp that we had. In this bootcamp, we'll be having the project on like 2 days, like day after tomorrow, not right now. Okay. Okay. Okay, so no issues in that. We'll keep today's class a bit short itself. We'll meet tomorrow. From tomorrow, we'll be starting out with the coding aspect of the same. So please be ready about it. There will be a lot that we have to do. Okay. Okay. So thank you so much, guys. I will show you guys the attendance link for today. How is this related to Python? Some of this stuff is like crazy, crazy right over here. Crazy. Okay. So you need to understand one thing. Okay. That Python is basically a language. Okay, Python is just a language that is there, a way of programming something. Okay, the concepts are something that you program. You don't require Python to actually program it. You can actually create deep learning projects by using JavaScript. You can create deep learning projects by using Java, C++. You can create it by using C Sharp. So that's totally up to you. So for example, when you're working on edge devices, okay, for example, you want to create an IoT device that has some kind of deep learning inside of it, you aren't going to be an idiot to write the code in Python. It won't even work on that device. You'll be writing it in either C++ or C Sharp. For example, you're working with a particular website. You want to create a website that has some part of AI inside of it. You'll be writing your code in JavaScript. You aren't going to be an idiot to write the code in Python. If you are working with something like let's say you're creating a Android application. In the Android application, you want to have like the front end. Inside the front end itself of the application, you want to have some AI. Right over there, you will be using maybe Java, maybe Kotlin, maybe even Dart for writing the deep learning application. You aren't going to use Python right over there. Python is one of the ways in which whatever concepts that you are able to learn, that is deep learning, you are able to implement it further on. Okay. Okay. So you guys wanted to see my resume as well. Give me a second, guys. I will show you my resume if I'm able to find it. I'm putting my display on blank so that I'm able to find it. Give me a second, guys. Give me a second, guys. Okay, so I've got my resume right over here. I wanted to show you one more resume, but I'm not able to get it. Okay, so this is one of my very early resumes that I created when I just left my college. Okay, when I started applying to various companies, as you're able to see, everything is like very plain and blank. There's nothing too great about it. Okay, there's no images, there's no like shapes or something like that. It should be as simple as possible. Sure, Asana, what am I? A software engineer. Okay, your GitHub accounts, of course, it's very important. Your mobile number and your personal email right over there. You need to have like a small introduction about you. Okay, what you have done, what you have accomplished. Okay, what is your aim in life? Okay, your education right over there. You should have your achievements listed out. Okay, so you have your like whatever you have achieved related to the position that you are applying for. What are the experience that you are having? Okay, so I worked as a software engineer, I worked as a data analyst, a data scientist, a machine learning engineer. You need to provide with the projects that you have worked upon. So for example, for me, my greatest one was the disaster query classification that I created, and along with that I had like 200 plus projects. Like I already have like 450 projects that I personally created in ML, DL, AI and deployment as well. So you are able to see that all these things are there. I'll show you one or two more resumes. I'm not able to get it right now. I think so. I will have to like contact somebody to be able to get it. But that is how you are able to like create a normal resume as soon as possible, guys. Okay. Okay, I need to create the attendance link for today. This is day 7. Am I right? As a fresher, what should you mention in your experience? So either if you have done some training or internship, then you can mention that. Otherwise, if you have no experience at all, then focus upon your projects. You don't have to mention your resume, your experience in your resume. Focus upon your projects. If you are a part of any club, any technical club, you have volunteered in any technical club, you can provide that as well. Okay, you can provide that as well. So there is no day 6. Okay, guys, there is no day 6, as you're able to see from the video itself. The day 6 was cancelled. Okay, so this will be day 7 today. Then we'll be having day 8 and then day 9. Okay, that we are able to maintain everything properly. For day 6, everybody will get the attendance. For day 6, everybody will be able to get the attendance. Okay, okay, let me just copy the link. What will the deadline for submitting the project and everything will be telling you guys once the project is over, not right now. This is today's attendance QR code, guys. You can go ahead and scan it, and then we'll continue with it from tomorrow onwards. Okay. Django is not a server side language. It's a backend framework in which you are coding in Python. So the language would be Python, guys. Okay. Siddhartha. It's there on our YouTube channel itself. You can go and see from right over there. Okay. Okay. So thank you so much, guys. We will be meeting tomorrow as well, and we'll continue from right over there. Thank you so much, guys. Thank you.